Hi, and welcome to a recording of our Workshop Wednesday series for August 2022 on data validation in Excel and R. In the video description below, you'll find links to the slides and notes for this workshop so that you can follow along. Enjoy. Other reminders, please ask questions as we go. The slides are available at this link. Also, after the workshop, I will make all the slides and notes and things available so that you can see that stuff afterwards. So there's also, before we get started, a little bit of setup stuff that I emailed out to everyone, I hope. I figured, just in case people didn't see this, you want to kind of see how this works. The beginning half of this workshop is going to be in Excel. The second half, we're going to be moving into RStudio, working in RStudio, learning how to do some programmatic validation of data. And so for that portion, and to get some of the materials that we're working with, this code will be helpful. So I'm going to actually just click on the slides. You can click this little copy button and it'll copy anything in those code chunks. And in RStudio, if you don't have the use this package installed, you'll need to install that, but I have it here. If I wanted to install it, I would just type in use this here and hit install. I'm not going to do that. And then I'm just going to paste that code in, this use course here, and that's going to download our course materials. And it's first going to ask me, it's going to by default put it on my desktop. That's totally fine. I can move it or delete it later. So I'm going to say yes, definitely. And then it's going to ask if it wants to, if I want to save the zip file or delete it, and I don't care. So I'm just going to say, sure, we can delete it. And then it'll download some data, and it should open up a new RStudio window here that has some files in it. So this is now on my desktop, and I've got the data, some of the data that we're going to work with, and a workbook that we're going to look at a little bit later. So my name's Eric. I work for the data science group that's part of the communications and cyber tech department in the College of Ag and Life Sciences. And we put on workshops like these. We do sort of data science consulting work and other things that I'll talk about a little bit at the end. But my background is in plant ecology. And so part of my motivation for hosting this workshop is that I've spent a lot of time, entering data by writing it down in a Write in the Rain notebook, or using other people's data or sensor data, and then, entering it in my computer and then going into data analysis. And there's so many steps along the way where things can go wrong, where you can write the wrong number in, you can enter it wrong in your computer, you can make a mistake in calculations. And so our goals today, overarching goals, is to catch those mistakes and those problems before they really happen. So we're going to talk about some best practices, general best practices for entering data. We're going to look at Excel's data validation tools, and those are going to help us prevent data entry errors. If you don't enter your data in Excel and you use another thing like Google Sheets or Apple's Numbers, there's similar tools in those too. And then we're going to talk about using the double entry method, which is a way of trying to catch mistakes in data entry and looking at some functions in R that we can use to catch those mistakes. We're going to explore some data summaries to check for errors. And then we're going to get familiar with an R package that I really love for data validation called Point Blank. Okay. So some general tips and general approach, thinking about how to deal with entering data to avoid and working with data to avoid mistakes. So my number one tip, if you come away from this with nothing else, it's don't edit your raw data. So once you've got your data entered, your raw data, keep that file separate, and any kind of calculations or manipulations you do to the data, do that on a separate file or do it programmatically. And that is going to prevent a lot of mistakes, or when those mistakes happen, you can at least go back to that raw data and see what happened, right? So enter your data and then keep that file separate. I often make that a read-only file so that I can't accidentally edit it even. And then I do all my data manipulations and analyses and error fixing in a separate file. Today, we're talking about data validation to identify errors like mistakes or physically impossible things, which is different than outliers. So statistical outliers are, extreme values that are maybe unlikely to be real, but there's no real way to know. They are actual things that you recorded. They're actual measurements that you took. And generally, what I tell students about outliers is to not do anything with them, is to leave them in your data. So here we're talking about things that are verifiable mistakes. Oops, I wrote a 7 and my handwriting was messy, and so I read it as a 1 and I entered it as a 1, right? Or things that are physically impossible, negative numbers of things, or temperatures that don't exist on Earth, things like that. We also want to record all our changes to the raw data. So when you're fixing those mistakes or changing values that are impossible, it's a good idea to record those changes in some way. And one really great way to do that is to do those changes with some sort of programming language like R, because then that code not only does the data manipulations and fixing, but it also is a record of what those fixes are. But we're not going to go too much into that fixing of the data today. We're going to be focusing on just catching the mistakes. It's also a good idea to flag any observations that have changed. So if you've got some extreme values that you go, no, I'm pretty sure that's impossible, and you change it, it's also a good idea to maybe add another column in your data indicating that that value has been changed, and maybe why. And that way, someone later on the line might actually say, you know what, actually, I think the original value is correct, and go back to the raw data or something like that. And yeah, like I mentioned before, this workshop is going to be focused on preventing mistakes. And keep an eye out for future workshops in this series or in other places at University of Arizona for tidying or wrangling data to learn some of the tools to sort of fix those mistakes programmatically. Okay, so let me introduce an example. And this is a real example from my PhD that's been modified a little bit. So I lived on a tea farm in Fujian province for like 2 months, and every day at 6 a.m. woke up and went out to our field where we had a bunch of tea plants marked, this is what a tea plant looks like. And at each one of these marked tea plants, we measured the length of 7 marked shoots per plant with just a ruler in centimeters to track their growth. And then we counted the numbers of these leafhoppers. This is a pest on tea. We counted the numbers of those leafhoppers on 30 or 50 leaves per plant. So flipped over the leaves, counted how many leafhoppers there were on a plant. And there were 3 of us, and we also recorded who took those observations down. So that's the data set that we're going to be or the example that we're going to be working with here. And so the first thing that I want to think about when I'm going to enter my data is think a little bit about how to kind of design my spreadsheet ahead of time. And spreadsheets are super convenient for data entry, but they can result in errors, and we're going to kind of take some steps to prevent that. So one thing we can do is use consistent values for categorical variables. So instead of sometimes saying a plant was dead and other times saying deceased or something in your notes, pick something ahead of time that you're going to use and use it consistently. Explicitly record any missing data instead of leaving blanks. That's going to help you catch mistakes. So not entering data, forgetting to enter something, is not the same as a truly missing value in the field. And if you are a little bit more clear to distinguish those, that can maybe help you catch some of those mistakes. So using something like an NA or a dash or something to mark actually missing values that weren't recorded. And for those column headings, put some thought into them. This is kind of hard and takes practice, but you want to use some consistent, concise, descriptive, and kind of easily machine readable column headers. And I really highly recommend this paper by Broman and Wu called Data Organization in Spreadsheets for a lot of really cool information about this. And date formats. It's best to use the ISO standard year, month, day. That's the least ambiguous format that's going to cause you the least amount of problems. So let's actually just go ahead and take a look at that that spreadsheet. So if you find the folder, sorry, I'm just shuffling windows around here. If you find the folder that you downloaded with that R code, there should be in the data folder, there should be a thing called datasheet here, datasheet.xl. So this is my data sheet, and this is pretty similar to the one that I use to enter data. I've actually made some improvements since I was a PhD student, which boy, it'd be pretty bad if I didn't. So yep, learned some lessons, and these are the names I've chosen. So I've got a date, right? Every day I'm going out, I'm going to record the date. There were two fields, A and B, so I'm going to record the field. I also wanted to know what time I was doing that counting, so I was recording the time. Every plant had a unique ID number, and then these are those 7 shoots for each plant, shoots 1 through 7. And so this is what I mean by sort of consistent column headers. They all start with shoot, and we're going to see later on that's actually going to be super helpful for our data validation in R. The number of leaf hoppers, counter is the first initial of the person that did the observation, and then the number of leaves per plant. So we've got different sort of data types in here. But right now, you know, by default in Excel, I can enter whatever I want in any of these, right? So for shoot 2, you know, I could enter in hello, and Excel is not going to stop me. Obviously, that's wrong. And you know, for plant ID or for field, it's supposed to be either A or B. Those are the only 2 fields I had, but I can enter C. So we want to do some stuff to help us catch these mistakes. So we're going to use these data validation tools in Excel to help us catch these mistakes. So the way to set these up, we'll start with something like the hoppers column here. I want to select all the columns in that, or all the cells in that column, and I can do that by clicking on this top little L thing here, except for the column header. And so on a Mac, I can deselect a single cell if I hold Command and click. And I think on Windows, it's probably Control and click. Because hoppers is allowed to be text, but everything else we want to be numeric. Oh, I just let one more person in the room here. Okay, so we want all these cells to be restricted to only be numeric. And so the way that we're going to do that is in the, let's see, data menu here, there's a validation thing. Now there's another way to get to this in the toolbar that we can look for later, but for now we'll do that. That brings up this little pop-up dialog box where I can choose what kind of value goes in there. Now hoppers has to be a whole number because it's a count, and it's the number of leaf hoppers. And it also has to be 0 or greater. And so I think if I put 0 in here, I think that'll include that. I'm not entirely sure. Let's try it out. So we're going to say, oh yeah, here we go. That's what I meant to do. So we want it to be greater than or equal to 0. We can have 0 leaf hoppers, but we can't have negative numbers, and it has to be a whole number. So when I hit OK now, if I try to type something in here like, hi, I get an error. And it tells me, you can't do that, right? And so I have to retry. If I put in 0, it works. If I put in 11.1, not a whole number. So it catches that mistake where I, accidentally hit the decimal key. If I accidentally put in a negative number, it also catches that, right? So this is going to make sure that we don't make any mistakes that are like typos, basically. Now, there still could be mistakes in our data, and we'll deal with those later, or there still could be data entry errors.
Eric, you have a question in the chat?
Oh, yeah. Let's see. Missed something. Where is the data validation tool found? Yeah. So after you select your column or your cells, there's 2 ways to get to it. So in the menu, there's data. There's a data menu, and there's a validation option here. I'm not sure, maybe it's not there on all the versions of Excel, but hopefully. And then also in the toolbar in this data tab, there's a data validation button here. And you can click this data validation option there to get it. So let's do another example here, the counter, right? So this one is the first initial of the person that did the counting. So it's going to be text. And custom, we're going to choose, oh no, what are we going to choose here? Any value, whole number, list. Yes, list. So a list is going to give us, we can put in the possible values here. For all of these, they have this little button where you could go and select something on your spreadsheet, but I'm just going to type this in here. So we can have W, G, or E. Those were the three possibilities. And I just entered those in with commas. So now if I enter a W, a G, or an E, it works. But if I enter an F, it tells me that's not a possibility, right? So that prevents me there from doing some typos for this column, which is the the initials, first initial of the person that did the counting. For date, we can take a look at what our options are there. So we have date here. We can select a, we can set a start date and an end date, right? So I could put in, these values have to be between, July 17th and July 30th or whatever the length of my experiment was. And it will also require them to be dates. So let's just say it's less than today. For simplicity. And I think I can just do it like this here. So we can enter our date in here. So now if I enter a date that says August 25th, it's going to tell me, well, let's try it with one that should work first. Yeah, so August 23rd works, yesterday works, but if I put in August 25th, it gives me an error. And I could also enter this as, the year 2001. That works too. You notice we haven't kind of done anything with the way dates are formatted yet. So we're going to look at that in a second. But let's go ahead and see if there's an option for time. Yep. So again, time, I know that it had to be between 5 a.m. and 7 a.m. We're kind of learning as we go here. I think I have to actually write that out as 5 o'clock and 5 o'clock a.m. There we go. So now if I put in 6 o'clock, that works. But if I put in 8 o'clock, I get an error, right? So we have these options for a number of different types of things here where we can, and I guess the one we didn't do was the numeric here. So a decimal value, right? So we have a decimal value here. And again, we could set some limits here. So, there weren't any shoots that were taller than 30 centimeters, right? So I could say, well, it has to be under 30 centimeters. So if I put in 20, it's fine. But if I try to put in 49, I get this error, right? So yeah. And another thing we can do, actually, if we don't want it to be an error, we can adjust that. And we can say here in this panel, there's these other tabs. And so we can go to error alert. Let me actually change it for the whole column. We go back to our data validation. And let's change this from stop to a warning and see what it does. So now if I try to type in 50, it says this value doesn't match the data validation restrictions. And I have a choice, yes or no. And if I say yes, it enters it anyways. So this is useful if your validation limits are like, I'm pretty sure there weren't any shoots that were taller than 30 centimeters. But then if you go out and you actually find one in your data set that's 31 centimeters or whatever, it just gives you that little extra check and says, did you mean to enter this? And you can say yes. And if we set it to the third option, which is information, and we try to enter in something that is too big, it just comes up with an alert, and we just hit OK, and it enters it anyways. So that's probably the more useful one if you're sort of expecting maybe there's some shoots bigger than 30 centimeters. It's not physically impossible the way that negative counts of hoppers is. so I just want a little alert reminding me.
I actually have a quick question. You may have already said this, so I apologize,
No,
but
don't worry.
for setting data validation criteria, is that something that you can only do before you start entering data,
Oh, yeah,
or can you apply criteria after the fact?
that's a great question. So let's put in some data here. And if we want to add data validation to these cells where I've already entered data, I can follow the same steps and I can say, you know, let's allow decimal, and it has to be, let's see, I have a value in there that was 30. So let's say it has to be less than 25, just so that we get some that are. And you notice nothing changes here, but what we can do in this data toolbar is we can click on the little arrow next to this data validation button, and we can say circle invalid data. And it didn't work. Oh no, it's thinking. For some reason, this takes a long time for it to do, probably because it's checking every single cell that I've added a validation to, which is a lot of empty cells. So Excel's not doing this terribly efficiently, but there you go. So it draws some red circles. And so yes, you can do this after the fact, after you've entered data. You can use the data validation tools on already existing data sets.
Awesome,
Thank you. That was a great question. And then if you want to get rid of those circles, there's an option here to clear the circles and just removes them because they're just a visual thing. Okay, so the next thing we have to worry about is Excel's extreme desire to turn things into dates. So this is actually a really big problem in science. This paper here from 2021 found that 30% of published papers on genetics contain mangled gene names because Excel thought the gene name was a date and converted it into a date. And so Excel is very, very keen to change things into dates. And I can kind of demonstrate that. So, you know, here in this column, let's say here, let's use field for an example, or actually I'm going to add another column called notes. Sorry, I'm jumping around a little bit. So let's say we've got this column notes and we set our data validation up so that this has to be, actually, in this case, we wouldn't have a data validation, right? Because notes can be whatever. You know, and if I accidentally type something in there, like 3/2, right? It's going to turn into a date. Now, if I do it in one of these columns, I don't think we're going to have that problem, but let's check it out. Yeah, it's going to say it doesn't match, and it's going to give me a date there. But it's very eager to convert things into dates. Anything that looks remotely like a date. So decimal points are okay, but if I accidentally push a dash instead, it thinks it's a date. If I accidentally do a slash, it thinks it's a date. If I you know have some start that looks kind of like a month name, maybe even if it doesn't necessarily need to be a month name, it converts it to a date. So the way that we can prevent this behavior is we can change the column type. So for notes, for example, we don't want this to be just any old thing. And so the default here is general, is the column type. And we want to not use general because general means it's like, I don't know what you're going to type in there. I'll figure it out. And we don't want Excel to figure it out because it's going to figure it out and in wrong ways and mess us up. And so we're going to actually want to go through our columns and specifically say, this is text. And so now that this is text here, if I type 4/3, it doesn't convert it into a date. If I type OG5, it doesn't convert it into a date. And so we want to probably do that for all of our fields, including the ones that are supposed to be dates. So this column, and again, I'm going to select the whole column except for the header. And I'm going to go up here and I'm going to say, this should be a date. Ooh, that's weird looking. So let's actually go and click on more number formats and see if we can figure out what we can do. So it's these hashtags here are because we chose a very long format that doesn't fit in that column. But we can go through and we can decide what we want our dates to be. And so we can use this here is that ISO format, year, month, day. So I'm going to choose that. And so now any date that I enter in here, I think, if I did it right, yep. So even when I do these kind of shorthand things, August 3rd, right, it converts it over into this format. So it's a lot easier to read. So we want to use those tools wherever we can. I think we've got one for time as well here. Yep. So it's going to format it so it looks nice. So if we type 5 o'clock, it's gonna format it in a way that it's going to be, hours, minutes, seconds, AM, PM. And that's going to help us avoid this kind of issue with Excel. So my number one tip here for this slide is to just make sure that none of your columns have that general thing on there. Even when it's just text you're entering, make sure you explicitly set it to text so Excel doesn't get overzealous about dates. Cool. One thing that we can do, one strategy for entering data in a way that helps us avoid data entry mistakes is to do the double entry method. And so this is really great if you've got maybe an undergraduate working in your lab that you're asking to enter data, and then you can also enter the data. And then you can compare those two versions programmatically to see where there's any mismatches. And that's a spot where you should go back and double check your data sheets and see where the mistake was. So this doesn't really apply to data that already exists using other people's data or using publicly available data or sensor data, but it definitely is useful when you're entering data from a paper notebook or something like that. So in that data folder, there's two versions of a data set, one entered by me and one entered by Jessica. Not actually, again, this is just kind of made up. It has these have a lot more mistakes in here than I would hope that you would normally find, but I wanted to demonstrate mistakes, a large number of mistakes in a short amount of space. So we're going to move over to our studio here. And this is that project that I created at the beginning. So in this data folder, we can see now that there's this T Eric and T _ Jessica, and that's what we're going to use for our checking out our double entry. So if you open up this workbook.rmd, there's some stuff in here already. And I think from the workshop poll, there are a few people that maybe are not super familiar with working with our Markdown documents or our studio. Oh yeah, first thing, these packages are the ones that you need. And so if you try to run this and you get an error that package doesn't exist, you'll need to install it. And the easiest way to do that in our studio is with this packages tab. There's an install button and you can just type in the name. So if I want to install VisDat, I can just do that. It's telling me it's already loaded because I already have it and I already loaded it, but whatever. We'll go ahead and install it just to see what it does. So yeah. So if you don't have these packages, go ahead and install them. And if you're not super familiar with our Markdown, don't worry about it. Basically, the stuff in this black background is text and you can type whatever you want here. Doesn't matter. Won't affect the code or anything. And then in these gray boxes here is where there's code that's actually run. And if you just want to run all the code in the box, you can hit the green arrow and it will run it all. And if you want to run one line at a time on a Mac, it's you can put your cursor there and hit Command Enter. I think on Windows, it's Control Enter. Oops, I want to actually make this. Yeah, it's better. Now you can see the little keystroke thingy. So this is just like basically some notes in here. But if we kind of move down to where line 38 here has the double entry method, and I'm using this read _ CSV to read in the data into R. Now, these are CSV files, comma separated values files, which you can export from Excel. There are also R packages to read in data from Excel. What is it? Read Excel. Yeah, Read Excel is a good package if you're looking to read data directly from Excel, maybe an Excel workbook with multiple sheets. But for simplicity, we're going to use these CSV files. So I'll go ahead and run both of those. It's going to give us a bunch of output here saying that it's read in the data and what the columns are, and it takes some guesses as to what the types of the columns should be: dates, times, character. DBL stands for double, which is our way of saying it's a numeric variable. It's got decimal points. And if we just type Eric and run that, we can see a little preview here of what the data set looks like. So this has 60 rows. Somebody asked, what is the function for read underscore CSV? So that should be available if you run this tidyverse here. If you load the tidyverse, it's in the readr package. Yeah. So yeah, so we can preview our data here, and the same thing with Jessica. We can preview our data here. And instead of going through these or printing them out and looking back and forth, we're going to use R to compare them. And there's a few different ways we can do that. The first way we're going to do it is visually. And so the VisDat package has a lot of nice functions for doing sort of visualizing data frames. And VisCompare compares two data frames. Now they have to be the same dimensions. So if we made a mistake like I forgot to enter a row, this is going to give us an error. But in this case, in this example, they both have the same number of rows, same number of columns. So this works, and we get a plot. And this plot highlights cells, basically, of our spreadsheet where the data is the same and where it's different. And so we can see there's some problems here, especially in this last row. There are some differences between those two data sets. So it looks like maybe I might have skipped a row, or maybe Jessica skipped a row of data. We see that there's some problems with some of the chutes where there's some discrepancies, and so maybe there's some data entry errors there. So this gives us kind of a visual overview of what the discrepancies are. Now we're going to do this in a way that's a little bit more informative with actual numbers here. And we're going to use this anti-join function. So a join is a way of combining two data sets, and the anti-join is maybe one of the least used types of joins, but it's really useful in this case because it's going to give us every row. It's going to give us rows that differ between the two data sets. And so if I run it right now, I'm going to skip this for now, but if I run it right now, I get this output here that shows us these are the values in Eric that are different from the ones in Jessica. So there's quite a few rows here that have differences, but this is still kind of going to be difficult to go back and troubleshoot in my spreadsheet. So one thing that I like to do before this is to add some row numbers to our data. So right now, we don't have an indication of the row numbers in this. And I'm going to add row numbers that are like the Excel row numbers. So the header in Excel, right, is row number 1. And so the data actually starts on row number 2. So that's all that this code is doing here. It's creating a column called row that starts at 2 and goes through the length of the data set plus 1. And it's putting that column before the date column. So if I run those, and then I take a look at Eric, now it's got this here that just tells me what row on the Excel spreadsheet is this. So when we do our anti-join again, now we can go check it out, right? So row 11, there's some discrepancy between Eric and Jessica. There's some value in Eric that is different than what's in Jessica. And if I flip these, the order of these, if I go anti-join Jessica, comma Eric, I get the values that are in Jessica that are different than in Eric. So again, row 11, there's something that's different. So we can kind of, if I run both of these, then we can look at them both by clicking on these little panels here. And we can kind of click back and forth, and a few things probably pop out, right? So if you spot something, if you spot a mistake, as I switch back and forth, type it in the chat, what the discrepancy is. This one here is probably my messy handwriting, a 1 and a 7. Yeah, Jeremy spotted this decimal point mistake here, 21, 2.1, right? So I just entered the decimal point wrong, or forgot to enter it in one spot, something like that, right? And we can kind of go back and forth and do that. We can then see the row number, and we can go check out our raw data sheet, figure out which one's correct, and fix it, right? So in this case, like I've skipped all those steps here of going back through your raw data sheet, saying, oh no, it is actually a 1 and not a 7. Or, oh, nope, that's supposed to be 2.1 and not 21. And oh yeah, there's a whole row missing for Eric's entry here. He forgot to enter the last plant here in it. And go back and fix those. So I've already done that fixing. And I've called it t_resolved.csv. So that's our, yeah, here's our viz compare, anti-join thing. So, so far we've kind of gone through like how to catch data entry errors. But now the next step, we're going to say, all right, we've fixed the errors that we could catch in the data entry, the literal like typing in the numbers from our paper right in the rain notebook or whatever. And we fixed those. And now we've got this data set called t_resolved, where we fixed them. And I'm going to read it in as a data set called T. From this point on, any mistakes in the data are a little bit harder to verify, right? Because as far as we know, everything in our computer is the same as what's in our Write in the Rain notebook, our data sheets. But we can still take some steps to validate the data, because there still could be mistakes, right? I could have written down something wrong in the field that doesn't make sense. I can't, have a plant shrinking by, 20 centimeters in a day. Like that doesn't make any sense. It's got to be a mistake. So we can still think about what values are possible, what values are reasonable, and we can kind of flag those values and go back and check them in the field, or decide if we want to maybe potentially treat them differently in our data or something like that. So one thing to start with is just exploring the data with some different ways of summarizing it. And you can actually catch a lot of weird, funky things about your data just from some kind of exploratory data summaries, data visualizations. You can't check for errors if you don't actually know what's supposed to be there in your data set. One package I like a lot is the skim_r package. This notation, by the way, if for those of you that haven't seen it before, is the name of a package, : name of a function. And this is actually valid R code too. You can run it like this without having to load the skim_r package with library. This code will work. And that gives us a nice formatted summary, which will help us kind of look for the number of unique values for categorical variables, and actually prints these little mini histograms for numeric variables, which can help you catch really extreme values. And in the slides, it looks something like this. So when I run it on that T data set, I get a data summary that tells me the number of rows and columns, tells me that I've got 2 columns that are character, or that were read in as character, one that was read in as date, one that was read in as time here, diff time, and 10 numeric columns. And then it's a little bit hard to see on the slides here because you have to scroll, and I'll show you in RStudio in a second. But it tells us for the character variables, we've got field and counter. It tells us how many are missing, what fraction are completed, 100%, right? And then for date, tells us the range. So right there, we could potentially see if there was something wrong, right? If there is a date that happened outside of our range. Tells us how many unique dates there are. And for time, same kind of thing. Now, this is a little weird because the way that R handles times is as like the number of seconds from some arbitrary date in the past. So this isn't super useful here, but it's not like easily interpretable, but we can still see there's 6 unique times. Maybe that's helpful for us. But what's really helpful, I think, is the numeric variables here. Tells us if there's any missing. So there's 4 missing observations for shoot 4, 4 missing observations for shoot 7. Maybe those are mistakes. Maybe those are actually missing observations because that shoot died or broke off or something in the field, so I stopped measuring it. We could go back and check our raw data, and it gives us some summary statistics, and it also gives us these nice little histograms. And so these are sometimes actually really useful. So here's an example here where the number of leaves, well, actually that's either 30 or 50, but here, number of hoppers, we see there's a really long tail on that, right? And the maximum value is 15, which is a lot bigger than the median value of 2. And so maybe that's actually a mistake there. Maybe I didn't actually see 15 leaf hoppers on that day. And so that's actually there, an indication for me to go check something if there's this really long tail or like a funky distribution in that. And I'll just switch over to R to show you what it looks like if you're running in R. So here's my code to read in my resolved data set. I'll run that. And this skim R, skim T actually prints out a series of objects here. So this is the data summary. This is the categorical variables. This is the date. This is the time one. And then this is all the numeric variables. And it has that little histogram here. It's a little bit harder to read this way. And we can also, this is what it looks like in an R notebook. But if we just ran it in the console down here, we could also see what it looks like there. Yeah, and we get those little histograms. So, yep, that's the skim R package, or part of it, I think is really useful. Now, back to that VizDat package. There's another function in there called viz_guess. And this plots its best guess of the type of variable for every observation. And so this is different than just asking what is the column type in R, right? So R stores numbers as numeric vectors, and it stores text as character vectors. It's not doing that. It's going cell by cell, basically, and asking, could this be a number? Could this be a date? What is it? So here's an example where I'm changing one of the values of field. So if I type, T $field, that's the field column of the T data set, and the 10th value of it in square brackets there gives me A. So it's supposed to be either A or B. I could change it to the number 1 here by assigning that to a 1, but that doesn't change the type of the column. It's still a character. So it's 1 in quotation marks, just text. And when we run VizDat vizguess, we get another kind of similar looking visualization here. But now we see there's something going on with field here, where it's red, which corresponds to character for most of this, but this is the one that I edited and introduced that mistake purposefully. And it says, that looks like an integer to me, right? And interestingly, we kind of get some stuff going on with the shoots here too. So most of these, it says, are type double, which again in R is the numeric type of data that can have decimal points. And then some of these, it says it's an integer. And that's probably just because I was measuring, it's probably just because it was exactly, 10 centimeters or something there. But we might want to go back and check those and make sure that there's not supposed to be a decimal point after those. These probably aren't mistakes, but this is, right? Hoppers should not have a decimal point. That's supposed to be a count variable. So there is a mistake there. And so, somehow that got past our double entry method. Maybe it was written down wrong in the data sheet or something like that, but we need to figure out what's going on with that, right? So vizguess gives us a nice kind of visual overview again of kind of what's going on, the data types. All right, and now I'm going to introduce this point blank package. And I'm sorry for I know there's at least one person that's been having trouble installing it, and I'm happy to stick around later or after this to see if we can figure that out. But if you couldn't get the point blank package installed, I think it's still helpful to kind of watch here and see what's available. So this is a really cool package. It's probably overkill for most of us in the room, but it's got a lot of cool stuff in it. And I really think it's a cool way to provide these really impressive looking and useful functional data validation reports. So we're going to use this this data quality reporting workflow that it has. So on their website, there are some really great documentation, and it's got 6 different ways to validate your data. We're using the first one. So here's how it works. We start with a data frame, like our T1. We create an agent. And so this agent is going to interrogate our data. We give it a bunch of validation steps. So basically the questions that it's going to ask of our data. And then we use this interrogate function. And our agent will interrogate our data and have some intel that it can report. That's kind of the overview here. So the way it works, the first step is we can decide on some action levels. And this is basically how many rows in our data set have to have something wrong with them before it tells us there's a problem. It could be an exact number. We could say if there's 1 or more data sets, it's a problem, right? So in the case of like the hoppers one, checking to see that they're whole numbers. If there's a single value that's not a whole number, that's a problem. I want to know about that. But for other things, maybe we want to know if some fraction of the rows, if there's greater than some threshold fraction, are a problem. And so in this example, I've said, I want you to warn me if there's 1 or more rows that fails some validation step. And I want you to really give an error if more than 5% of the rows are failing. That's what these action levels are. So when you create this, I saved it into a thing called AL, and it says action levels, warn failure threshold 1 test units, stop failure threshold 0.05 of all test units. We'll come back to what this does later. Then we're going to create our agent. We use the create agent function for that. So the first argument we give it is our data set. In this case, it's this T data set. And then we're going to give it the argument actions, our actions that we created, our action levels we called AL. And we've got our agent now. That agent, then, we need to give it the questions. So we're using the pipe here. This is the McGritter pipe. There's a shortcut in R, and I'll show you in a second how we can type all this out in RStudio. But we're going to pipe that in to the next function, which is one of our validation steps. And this is checking that the column, checking that a column is a date. And we're going to tell it what columns to check, the date column, right? So we're telling it, check that the date column is in fact a date. Here's another example where we want to check that the field column only has a certain set of variables, right? It can only be A or B. So we're giving it a vector, A and B, that has A and B in it. And we're saying call vals in set. And then the next one here, we're checking that all of the shoot columns should be less than 15 centimeters. And here's where our column naming pays off. We don't have to type out shoot _1, shoot _2, shoot _3, shoot _4, and so on. We can use this little helper, starts with shoot _. So this is going to select all our columns that start with shoot _. And those are the columns that are going to do this validation. It's saying to check that the values are less than, call _vals _LT for less than 15 centimeters. But missing values are okay. They're not errors. And we'll go through this in R a second, step by step, just kind of giving you the overview. And then the last step is to interrogate it, interrogate the data with the interrogate function. And that gives us this beautiful validation table, beautiful and functional. So we can hover over things and we can see some more information about what each step is. So here, expect that date. Column date is of type date. Expect the values in field should be in the set of A and B. Expect that values in shoot _3 should be less than 15, right? This tells us what columns the validation was run on. This tells us the values that are expected for that. It's not always appropriate. So for date, it's not expecting a particular value. It's expecting a particular type. It tells us that there were no issues like running the code to do this check. It tells us here how many rows were checked, basically, or how many things were checked. In this case, it's checking a column, so it's just one. It tells us how many pass and how many fail. So 59 rows passed this, but one of them failed, the one that I changed from an A to the number 1. And that gives us a warning because we have one or more rows. The coolest thing about this, though, is that I can click on this CSV button and I can download a CSV file of just the rows that failed that validation step. And that's not it. This is it. So these are the 3 rows that failed this step here, that the shoots should be less than 15. And so I can go and I can look and see, wait, was that the one? Oh yeah, here it is. So we got a shoot that's 15.3, 15.5, that's fine. Those are reasonable numbers. And 16.6, I might want to go back and double check that, but it's probably reasonable, right? So that is my favorite thing about it, this little CSV button that lets you download stuff. So then you find just the subset of rows that might be a problem. You can go back to your raw data sheet, you can double check them, you can go back to the field, you can double check them fairly easily. So, and it also tells us our action levels up here. Now there's one here that I didn't use, notify, and this is again, like, this is totally overkill for what most of us use, but you could set this up on some automated pipeline sort of system that runs every few minutes, or it runs as you're collecting real-time data, for example. And that notify threshold is how many rows have to fail before it sends you an email. So you can actually have it notify you in some way, send you an email and say, you know, hey, something's up with your data. And if the sort of built-in validation functions that exist in Point Blank aren't good enough for you, because they aren't always good enough for me, there's this call_vals_expr, which allows for you doing very flexible sorts of things. You can pass any kind of expression or function into them. And so one that I often do, and included it in the slides because I thought it's probably the most useful of sort of the custom things, is to check that something is a whole number. Now there is a function to check if a column is an integer, but your column might not always be actually appropriately an integer, but it might sometimes need to be a whole number. So for example, if you measured to the nearest centimeter, right, you shouldn't have decimal places, but it's not an integer really. So the way we do that is with this modulo operator that returns the remainder. And if we take our value here of hoppers, the number of leaf hoppers, and we do this modulo 1, it should be 0 if there's no decimal places. So we can add that one in and see what the report looks like. So let me go over to R, and we can check some stuff out here interactively. And I'm also happy to answer any questions. So we're going to code here. The Point Blank package, by the way, it is like really, it's in active development, and the package author, Rich Iannone, is super responsive. So if you do play with it and try it and you find any mistakes or bugs or you're confused, go to the website, ask a question. Somebody will answer your question, or you can ask me because I've used it. So here we are setting our action levels. And this again is what determines in that report what counts as a warning and what counts as an error. Basically what turns yellow and what turns red. Here's our agent and some validations. So, you know, we can add some things to this, for example. So I can do a shortcut to type that pipe, Command-Shift-M or Control-Shift-M on Windows. And then if I start typing call underscore, I can kind of see my options here from the Point Blank package of what we can do. So we can check that a column is character or date or factor or integer or whatever, logical, true or false, right? Numeric, POSIX is like a time class. We can check values are between, values are decreasing. So if you had a table that was sorted in a certain way and you expected the values to only get bigger, that could be useful. That's one way of sort of checking that, you know, things that are growing things that should be growing are actually growing, right? If it's impossible for a plant to shrink in size, then you might sort by date and then check that the values are decreasing or increasing. Less than or equal to. So there's a ton of options here, and the documentation is really nice. So if you want to see more about one of them, call vals not between, we can always type question mark call vals not between, right? And run that. Oops, want to run just this. And we get our help file, right? So lots of documentation. So I think it's pretty well described how to use all this stuff, and there's a lot of functionality here. So I'll just show you what this one looks like. And then there's some suggestions in here in this workbook for you guys to try adding some validation steps for checking, for example, that the hoppers and the shoots columns and the leaf columns are numeric, checking that the counter column should be in a set, W, G, or E, checking that plant ID should be between 1 and 20, checking that there's no missing values. And so if we want to spend a little bit of time playing around with this, we can. So one really cool thing that you can do with these point blank validations that I think makes them really powerful is you can publish them. So this R Markdown document that we've created here, we can actually hit the knit button here. Let's see if this will work. It might break because I've got some code that probably doesn't run. But if we, let's see, maybe it's working. We can create a document, or we can create slides or whatever that include those reports. And this is a really nice way of sharing with collaborators. Yeah, of course. Let's get rid of some things here just so I can show you what it looks like. So that should run, right? Yes. Okay. So while that's working, you can share these documents that have these point blank tables in them as a website, as an HTML document. You could email the HTML document to your advisor or your collaborator or whatever, and they can click on those buttons still. They can open it up in a web browser, or you can share it on a website if you have the ability to do that. Here at University of Arizona, we have access to RStudio Connect, which is where these slides are being hosted. And that is a really easy way to publish these things. Once you've kind of got it set up, there's this little button here in the corner, this publish button, and that will let you publish it, one-click publishing to RStudio Connect. And it looks like maybe it's working. Yes, it's working. Oh yeah, here it is. So here's our document that we created in the corner here. And if I scroll down, we'll see these tables are here. And if I wanted to publish it to RStudio Connect, it's a one-click thing. And I can publish that document as a website basically, and I can send that to my advisor, my collaborator, or whatever. I can send them the link, and then they can interact with this table and click on those buttons and download the CSVs and all that. So that's a really great thing to check out. This sort of data validation can also be automated in a variety of ways. And like I mentioned, there's ways to get notifications and things like that. And so if you're interested in some more advanced applications of data validation for your work, for your lab, please don't hesitate to contact us. One really great program that our group does is these incubator projects where you can write a proposal to basically get 80 hours of my time or one of my teammates' time to work on some project related to data science. And for example, it could be some kind of data validation plan or something like that, potentially. We have office hours every Tuesday morning virtually that you are welcome to attend if you have more questions about this sort of thing. I'm happy to help you out and walk through stuff. You can also just make an appointment with me. There's a link there that'll take you to a Google Calendar thing. If you want to make an appointment to follow up on this, or if you have other data science type questions. And yeah, these are some references papers that I referred to in this. And that's it. So thank you all for coming. And I'm happy to stick around for a little bit and answer any questions or play around with point blank together, whatever you guys want to do.